Sir, you're on mute, sir.
I'm so sorry. I just clicked that button, but okay, never mind. I think I'm audible now, right?
Yes,
Everybody,
sir.
guys?
Yes. Yes.
Okay, okay. Thank you. So let us get started with our session over here for today. And what I wanted you guys to understand is now we would be starting with a very important aspect, which is called as NLP, right? So if you observe over here, there is introduction to NLP, tokenization, stop words, and most important part over here, apart from all of these things, right? So what I wanted all of you guys to understand is that first of all, there is again reading material that I have shared with all of you guys. You can take hold of this reading material if you want to. Just 1 minute. Uh, reading material. And by the way, there is like we are not going to have a lot of a lot of theory in this particular session because since you guys are already mentors, since you guys are already teachers working in well-reputed organizations, so I don't feel that these basic concepts are something that you may not be aware of. So NLP is basically natural language processing. What happens in NLP is that the raw data with which you're working, it is textual in nature. And since the raw data with which you're working, it is textual in nature, the processing that we are kind of expected to move ahead with, it is different from the traditional processing that we will actually try to complete. Okay, so that is like one of the key difference, or it is like one of the most important difference between these 2 points over here. Now the point over here is really interesting. The point over here is very straightforward, that it is very important for all of you guys to understand that we cannot work around with what you can say textual data as it is in what you can say in traditional machine learning. There is encoding that we used to do.
Madam.
Do you remember, everybody, guys? We used to do encoding over there,
Okay.
right? So basically what is happening
Set to
over
attend, huh?
just 1 minute, I think somebody
Okay,
was
okay,
not.
okay, okay. B007. How many micro teaching to be done?
So yeah, I'm so sorry. I think somebody was not on mute. That is why this happened. So let us resume with our coursework. So what I was basically saying over here is that introduction to NLP is like really a basic topic, that the data with which you would be working, it would be textual in nature. So let's say that you are reading or analyzing some reviews at Zomato. Hypothetically, let's say you're doing that part. So from the points that you're getting out of 5, 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, from the points, there is definitely one thing that you can figure out, that whether the person liked it or whether the person didn't like it. Okay, that is basically something that you can definitely figure it out. But at the same time, you cannot figure out the exact root cause analysis or exact problem that happened. For example, if a particular rating was bad, right? If hypothetically saying, if a particular rating was bad, then why exactly it was bad, or if a particular rating was good, why it was good, what was exactly the point? That is not basically something that you guys can kind of try to analyze over here, unless and until you do some sort of textual analysis. Is it making sense to all of you guys, everybody? So you cannot do that level of analysis unless and until there is some exact detailed analysis, in-depth analysis that is kind of applicable over here, right? So with that being said, let us try to move ahead. With that being said, let's try to get an idea. Or with that being said, let's try to move ahead with the topics for here. So if you see tokenization, stop word, stemming, lemmatization, all of these topics that are kind of mentioned over here, they come under pre-processing topics. So what basically happens over here is that you cannot pre-process the data. Everybody, are you getting my point, guys? You cannot pre-process this data as it is. I gave you a sentence. You cannot pre-process it because it's textual in nature, it's not numbers. And machine learning algorithms at the end of the day are something which can only work with numbers. That's it. So there is a predefined set of ways in which you have to pre-process the data, right, everybody, guys? And that is all of this: tokenization, stop words, removal, stemming, and everything. So let's try to get a small gist about all of these things. So I've already given you the reading material. I hope you can go through this particular part. And I have also included like a very small 1 or 2 lines of introduction over here as to exactly what is stemming, what is lemmatization, and what are the other parts or other aspects that are included over here. Okay, so tokenization, let me zoom into it. Tokenization is basically the process of, just 1 minute. Tokenization, just 1 minute. Tokenization is basically the process of what you can say, converting a paragraph into sentences, that sentence tokenization, and converting a sentence into individual words, that is called as word tokenization. So there are different aspects, or there are different levels over here for tokenization activity that is basically implemented, right? So if you decompose a paragraph into sentences, it's sentence tokenization, right? NLP is fascinating, it is challenging. So there are two sentences over here. And if you, NLP is fascinating, NLP is fascinating exclamatory mark. That's basically word tokenization. After that is completed, there is subword tokenization, in which a single given word with which you are working, that is basically something which is decomposed into two words. Unhappiness, it's made of two things, un and happiness. Okay, is it making sense to all of you guys? Perfect. So take 30 seconds, read it, and do let me know if I can help you with anything. Everybody, guys. 30 seconds for all of you for this. And then we will move ahead with the live coding session for the same. So now after this is done, let us try to move ahead with the next part, which is stop words. Do you guys know what is stop word removal? Is subword tokenization same as word piece tokenization? Yes, that's the alternative name to that, Shivani. But I have not seen this particular portion being implemented in industry that frequently. Okay, to be honest with you. Okay, I have not seen that subword portion or that space being implemented. Perfect. Now let's try to move ahead with stop words. I want you guys to tell me what is stop words. Everybody, guys. What do you think is the meaning of stop words? Everybody, guys. Can you tell me what is stop words, guys? Everybody. Correct. No, so it basically so there are some examples of stop words exactly. So what are stop words? Conjunctions is one type of stop words. Anybody else? So in very simple words, stop words are basically the words which do not carry any specific meaning of their own, and they just increase the dimensionality of the data. So when you are tokenizing the data, what happens is that there are different tokenization techniques in which every given unique word that you have, it becomes a column, right? Every given word that is basically present, it becomes a column. Now let's say that there are some useless words like conjunctions, prepositions, which do not carry any discriminative meaning about the target variable. Let's say that there are some words, okay, and those words are not having any discriminative meaning about whether the given email is spam or not. So having those words in our analysis just increases the dimensionality of the data with which we are working, and nothing more than that. Okay, having those things just severely increases the dimensionality of the data, which in turn increases the computational cost, right? That is basically present over here. So now after this is done, let us try to move ahead with stop word removal. So there is a bag of words, right? Called and like all the stop words in English, including the, is, in, and, like there is a very big list of that particular portion. So what basically happens over here is that if you want to remove the stop words out of the corpus of words that you are having, right? So that is basically something that you can do, and that process is basically called as stop word removal process. So it's one of the very important data pre-processing steps over here. So take 30 seconds, try to read about stop words, and I think then it's a better idea after that to do the live coding session for two things. First is tokenization. Second one is about just 1 minute. NLP session one, live coding. So I hope you guys are ready with the fresh Jupyter notebook. If you guys are not using Jupyter notebook, that's also fine. You can use Colab, VS Studio Code. That doesn't really make a difference. Okay. Now, after this is done, let's try to move ahead with something called as word tokenization. Okay, import NLTK, NLTK dot download Punkit. Punkit is basically something which will really be useful for getting the other aspects over here. We will discuss about this Punkit as well in detail. From NLTK dot tokenize, you have to import word tokenize. This word tokenizer is basically something which will help you to tokenize the given sentence to words. Now sample sentence. So a sentence would be decomposed into words. So text is equal to hello and how are you doing today? Correct? Now after this is done, you have tokenized the text. Tokens is equal to words underscore tokenize text and print tokens import, my bad. So this is basically something which will help you import error NLTK dot tokenize import cannot import from NLTK dot import word tokenized. Okay, so hello, then comma, then how are you doing, each of this, and then question mark. These are the tokens in the data. So I will request all of you guys to write this code in your laptop. Everybody please try to write it in your laptop. So after this is done, what we would be doing is that we would be doing sentence tokenization over here. Everybody, are you good to go? So type it in your laptop and then do just 1 minute. Yes, perfect. Yeah. So now let's try to move ahead with next part, which is sentence tokenization. So in sentence tokenization, what is basically happening is that from NLTK dot tokenize import sent underscore tokenize sample paragraph, because a paragraph would be decomposed into multiple sentences over here. So text is equal to hello.
Sir, can you copy this code in one shared document, or it's a better
I will
shared
give
document?
I will give this file to all of you guys, this coding file.
Coding files.
Yeah, at the end of the session, I'm going to give it to you. Don't worry. Okay. But if possible, please type it. I'm expecting you to type it along with me if possible. Okay. But any which ways, I'm going to give this file to you at the end of the session. Okay.
If you paste this part of code in the sharing document, it is a very
I'm going to share the file itself. No. So don't worry about it. I'm going to share this file itself. Don't worry. This NLP1 file is something that you will get.
no.
Okay. Then you are having a great day. Then we have let's go learn NLP together. So how many sentences are there? How are you doing today? First sentence. I hope you're doing great. Second sentence. And then the third is this. Now you have tokenized the text into sentences. So sentences is equal to send underscore tokenize text. Print set tokenized sentences. Right, first sentence, second sentence, third sentence. So I hope this helps you. Take a minute if you want to write it down. We have ample amount of time for this, by the way. You can type it. So guys, can I move ahead with the next part? Everybody? Perfect. Okay. So have you written this code? By the way, I was waiting for you guys to type this. If some of you guys are want to type it. Okay. Perfect. Then you have stop words removal process. So in stop word removal process, what is basically happening is that whatever are the words which will not be useful to get some discriminative information about the target variable, that are the words which we are planning to remove. Correct, guys, everybody? So that is something that we will try to see. Okay, perfect. So now let's try to have the live coding for that. So there is a library, there is nltk.download, and then there is top words. Okay, and from nltk.corpus import stop words. Then you have sample text, in which text is equal to, this is a sample sentence showing the use of stop words filtration. Now you have the next big thing where you would be tokenizing the words. Tokenize the words, and then words is equal to word underscore tokenize text, and after that you have get the list of stop words in English. You have stop words in different languages also, by the way. Okay, as we are moving ahead majority with English language, that's why we use that. But let's say that you don't. I have worked with a project where I was not having the data in this required format, English language. I was having the data in French. So you can also remove the stop words of French language. So first of all, stop underscore words is equal to set. Set is a data structure which finds great usage in NLP problems because of its property to exclude duplicate values. So stop words now is a variable which will have the list of all the stop words, and now filtering the stop words over here. So filtered words is equal to word for word in words if word dot lower not in stop underscore words. It simply means that if the word is there in stop words, don't include it. And then print filtered tokens. So you will see that the stop words of English programming language lower WPR. So you will observe that this is removed, is removed, is removed, then the is removed, off is removed. Okay, so these useless words which will do nothing and which will just increase the dimensionality of the data with which we are working, those type of words are simply removed over here. Is it making sense, everybody, guys? So 30 seconds, guys, for all of you to type this. I think there is one comment over here. Yes, sir, written. Yes, sir. Okay, Chandraha is doing it. Okay. So it's very simple. Why? Can anybody tell me why I am writing this? What might be the reason that I am writing this? So there is a module named stop words. Like in NLTK, there is corpus, and inside that corpus, there is a sub module called as stop words. The reason that I am implementing this again and again is because of the fact, everybody, it is because of the fact that this stop words, right, is something which should be updated. So all the libraries that are available, they are updated at regular sequence. Modular packets are importing that. It's a sub module. So there is library named NLTK. Inside that there is a module named corpus. Inside that there is a sub module named stopwords. Okay, so it's like a sub module, but the reason why we are updating it or downloading it is because we want to make sure that it is up to date. So take 30 more seconds. We are updating the stopwords. I will write it over here. Updating the, my bad. Updating the stopwords. Okay. Always, whenever you run the codes, you have to make sure that it is up to date and it is executed with this particular block. So now after this is done, we have completed two really important activities in NLP, right? So first is about tokenization and second part is about filtering.
Sir, is there any difference between the import and the download? While we are importing all, that means it is all going to be included in the program in this phase itself.
Which one? Sorry, can you repeat it?
NLTK.corpus import stop words. So
So
it is importing all the stop words from the corpus.
from the corpus module, yes. So this is basically a sub module which has a function called as words, in which if you give English as the argument, so it will basically it is preloaded with
I'm
all the
asking about
stop words.
I'm asking about this NLTK.download stop words. I can
What it will do,
explicitly we need
is
to write.
exactly, you need to explicitly write it because this will download the latest version of stop words. So what happens is that this stop words also gets updated regularly. So what happens is that if you guys are doing this particular part or activity promptly every time, you will be sure that every time you will get most updated list of stop words. That's why you have to download it again and again. Is it making sense? To make sure that you get the best possible version of stop words, we do it. Okay, I hope that clarifies your doubt. Can you show how to Hindi or any other language? We will definitely move ahead with it. So problem with showing that is that Hindi is not, I think, a language in NLP 1. It's just that here you need to write French and whatever is the language. The problem is that I don't have that typewriter over here so that I can type it French, or I don't have the data in French. If you guys have, you can simply take a sentence in French and remove that particular stop words from that particular portion. Okay, take a minute for this, guys. So now after this is done, let's take the request of one of our candidates. pimple shade. So let's try to have removing stop words of French language. So what we are basically going to do is sample text. Text is equal to. Then let's go on Google a sample sentence in French. Mm, let's try to take this any sentence. Okay. And after that, you have to tokenize the words. You have to do all of this exactly same. It's just that here you have to write French. So see, to is not taken, day is not taken because these are the stop words of French language. Also, let's do one thing. List of languages in stop words NLTK. So here you will get the list of languages, okay, in which I don't think Hindi is there. Shizzes, Danish, Dutch, English, Finnish, French, German, Greek, Italian. These are the languages that can be done. As I told you, I thought that Hindi would not be available. Right? These are the list of languages, guys. Everybody. Right? Is it clear now? Uh, everybody, to all of you, is it clear? Perfect. So now after this is done, you can type it again if you want, you can type it. What is the meaning of this sentence? We don't like chocolate. I forgot the meaning. Let it be. Thirty seconds, guys, for all of you to implement this. Then one by one, what we will do is that we will keep on trying the other sections. Perfect. So let's try to move ahead and let's try to move ahead with the next activity. 1 minute. Yeah. Stop words is done stemming. This is my favorite, like one of the favorite methods, stemming and lemmatization. So stemming is basically the process of reducing inflected or sometimes derived words, right? Like running, runner, runs. All of them have the same root word or stemmed word called as run. So what happens is that different words are used in their different forms in different paragraphs, different sentences. And that is why this is basically something that we need to take into consideration. Okay, everybody, guys, is this clear? Now, after this is done, I think somebody is not on mute. So after this is done, there is one disadvantage about this particular method. The disadvantage is that this particular method is not going to give you it may not be a real world, but a canonical form of the word. So I have seen a lot of situations where the words that you get, they are not the actual words in the English language. Is it making sense, everybody, guys? So take 30 seconds, read this. There are different stemmer methods that we will try to move ahead with. Take 30 seconds, it's just this much theoretical part. And again, there is live coding after that. So everybody, guys, are you clear with this one particular concept? Yes, no, any confirmations for me? Okay, perfect. So now after this is done, there is another method that is available over here, which is preferred in industry, which is called as lemmatization, right? So what is this lemmatization? What do you guys think might be the difference between stemming and lemmatization, or what is the drawback of stemming, guys? Everybody, what is the drawback of this particular part? So basically what is happening over here is that stemming is not going to give you a word which is always there in English dictionary language, which is a problem for us. That is why it is lemmatization is used, because it is reducing the word to its base form or dictionary format, right? Known as lemma. So this is not taking into account the morphological analysis of the word, but it uses vocabulary and morphological to remove inflections. Very important line, read it. And here is the key difference. It considers context and parts of the speech and usually returns a valid word, whereas it may not return you a valid word. So take 30 seconds for this, and then we will move ahead with the live coding for stemming and lemmatization both. Right, 30 seconds for this, guys. Now, after this is done, let us try to move ahead with the live coding session over here. And what we are expected to do over here is stemming, and that too Porter stemmer method. We will do all the three stemmer methods. There is a difference between these three stemmer methods, for which I will give you reading material tomorrow. Okay, I will give you reading material that the mathematical equation and the way in which it is done, that's different. But we cannot discuss it in that much detail since it's not there in the coursework and since we just have 2 hours. But I will give you the reading material for that. Porter stemmer, right? Next is initializing. So here is importing important libraries. Initialize the porter stemmer method. Porter is equal to porter stemmer method. Simple words. Word is equal to running, ran, my bad, running, ran, runs, easily, fairly. Okay. And after that is done, you have apply porter stemmer method. So porter stems is equal to porter dot stem word for word in words. And then you print porter stemmer output, which is going to give us n comma, and here it is porter stems, not minus porter underscore stems. So running is run, ran will remain ran, runs will remain run, easily will become easily. See, here is the mistake. In the above code, easily and fairly are not valid words in English dictionary. Correct, guys? Everybody? That's the drawback of stemming method. So please take 2 minutes of your time to go through this and do let me know if I can help you with anything. So now after this is done, let's try to move ahead with snowball stemmer method. Stemming, but it is
Somebody is
done with
posted
the
in the charts.
chart. Yes, sir, that means that we should skip stemming process. Yes, we never do stemming in industry. As a mentor, I have to teach it to you since it's in your course curriculum, but people never use stemming, they use lemmatization. Yes, correct, absolutely correct. So as a mentor, I have to explain this to you. Otherwise, if I would was allowed to follow my course curriculum, I would have simply wrapped up stemming in one line that it's a irrelevant method. People never use it. That we directly would have moved ahead with lemmatization. Okay, so now we have importing important libraries, right? So from nltk.stem import snowball stemmer, initialize initialize the snowball stemmer method. So snowball is equal to snowball stemmer language is equal to English. Okay, now you have sample words. Words is equal to running, ran, runs, and seen easily, comma fairly, and apply snowball stemmer. All word in words. Print snowball stemmer snowball stems. So this is going to again give you, so results are different. See, easily is same, but fairly and fair, this result is different. So you can see that with different stemming methods, different results are obtained. And as I promised you, just give me some time after the session is done. What I will do is I will add the links over here. After that, I will add link 1, link 2, link 3. You can read about details of how Porter stemmer method and snowball stemmer method and every other stemmer method is working. Just give me some time after the session. I will add the links now.
But in this case, both are giving the same output, Mr.
For you, they are giving same output.
Yeah, same output.
It may happen,
Uh,
yeah,
there is a difference for fairly fair. Remaining all
absolutely.
are same.
Then now in my case, it's again given the fairly output. Same
In his
output.
case, yes, and that is because of the fact that there is a random state parameter in all of these stemming methods, right? So it's slightly random. If you fix that random state, it will be again same. Okay,
So how to
so
fix
like
that randomness?
that randomness is something which I think is there is a parameter help snowballs method help that I don't know the name of that parameter. I think here you may get it snowball stemmer method. German stemmer. No. Okay, give me some time. I will get back to you on this. I have never fixed it in my analysis, but I will get back to you how we change it. Okay. Now next part over here is one more method, which is Lancaster, or which method was available? isn't the stem word for run absolutely it should be, but it's not giving the correct answer. That's why this method is not correct. Lancaster stemming method. Okay. So Lancaster stemming method. Okay. So from nltk.stem import Lancaster stemmer. Okay. Then you have initialize the Lancaster stemmer. So Lancaster equal to and then you have sample words. Words is equal to running ran runs easily fairly. One more thing, you were getting the difference, but I just have one small question. So yeah, you do one thing in your laptop. You run exclamatory mark pip install nltk. Run this code, restart your kernel, and rerun that code and see if it is different. Do this part and let me know if it is.
Yeah, can you just tell me what is the command I need to
In
use?
the global chat I've given it.
Okay.
In the global chat it's there. Just apply it and run it and tell me if it is same or how is it. So this is the Lancaster stemming method. So here easy is coming correct and fair is also correct, right? So see, different methods will give you different results. So everybody guys, any questions? Now let's try to move ahead with the next activity, which is lemmatization. In lemmatization also there are different lemmatization methods. We would be moving ahead with wordlet lemmatizer. Okay. So ensure that we have up to date packages nltk.download wordnet nltk.download OMW-1.4, and these packages need to be updated so that the lemmatizer that you are going to use, it's giving optimal results. Okay. Libraries. So from nltk.10 import WordNet lematizer. Initialize the WordNet lematizer. Pairing, correct? And now after this is done, apply WordNet lematizer, lemmatized words is equal to lematizer dot lemmatize word or word in word, and then print lemmatized words. It's going to give us this part. So this is basically the most important. See, WordNet, it's downloading in my laptop. It was not updated. Even OMW 1.4 was not up to date in my laptop. And see, you can observe over here that no word has been changed apart from runs. No word has been changed apart from words, apart from runs. So take a minute, write this in your laptop, and do let me know if I can help you with anything, guys. So after this is done, I think we can move ahead with the next part. We can take a break of 10 minutes. And after the break of 10 minutes, let's try to move ahead with the next part. Right? So in the next part, we will try to continue the remaining options or the remaining activities that are there. 10 minutes break. Nothing changed exactly, apart from runs changing to run. Right? So we will resume at 15:17. 10 minutes break for all of you. Thank you. So everybody guys, it's 15:17. Let us get started with our session. So before our break, we have discussed stemming, lemmatization. Now there is something called as parts of the speech tagging, right? So in parts of the speech tagging, what is basically happening is that if there is a sentence, in that one given sentence, what basically happens over here is that there are different aspects, right? There is a noun, there may be a noun, pronoun, verb, adjective, adverb. So a particular given word, it may happen that it is being used as a noun, it may be used as an adjective, it may be used as a pronoun, right? It depends. So POS tagging is basically an automated way in which you can identify that in a given sentence, whether the given word is being used as a noun or whether it is being used as a pronoun or adjective or adverb, whatever it is, right? So the quick brown fox jumps over the lazy dog. The is DT. What is DT? All of these things are over here. Determiner, noun, noun plural, adjective, verb, verb past tense, verb gerund form, verb past participle, verb third person singular, adverb, right? Preposition, personal pronoun, possessive pronoun, CC is coordinating conjunction, cardinal number, existence there, existential there, sorry. Then FW foreign word. So there are 20 options which I have included for all of you guys in the reading material over here. You can take reference from this whenever you want. Okay. So after this particular section is being completed, what we take 30 seconds to read this, and after that we will try to do POS tagging over here. Okay. So now after this is done, let's try to move ahead with the next block. So here what we are doing is POS tagging. Parts of speech POS tagging. NLTK.download averaged perceptron tagger. Perceptron tagger. Now, the next part that we are basically having is sample text. Again, the text is same. Text is the quick brown fox jumps over the top. Okay, now what we are basically going to do is we are first going to tokenize the text, and tokens are equal to NLTK dot word underscore tokenize text, and then you have perform POS tagging. POS underscore tag is equal to NLTK dot POS underscore tag tokens print POS tags POS underscore tags. right? So you can see that this is basically something that you can do, parts of speech tagging. So please quickly try to complete it and do let me know if you are having any questions or doubts in this, guys. So you tokenize the given words, my bad, THE.
Sir, I have one query.
Absolutely, tell me.
Sir, here we are using certain examples like one liner text or four, 5 words for lemmatization. But when we are going to work on the data set, we want to reprocess a specific data set. So what we are going to we are going to call the data set specifically and then
We are going to call the column of that data set. Like hypothetically, let's assume that uh, there is a column called as subject. Let's say that there is a column called as message, and let's see, there is a target variable column denoting whether the given email was spam or not. So what basically will happen over here is that in a given word, you will kind of try to implement it. For a given word, you guys will kind of try to implement it. So for a given row, sorry. So for a given row number one, whatever is the message, that paragraph would be decomposed into sentences, sentences would be decomposed into words, and then what is the parts of speech of that word that we would be taking into consideration, and it is done for semantic processing. What's the purpose? Purpose of this is semantic processing. Okay, Vijay. So there are three types of processing in NLP: lexical processing, syntactic processing, and semantic processing. Lexical processing deals with the fact of presence or absence of a word in a given sentence. So just merely presence or absence of a word is related with lexical processing. Semantic is that grammatically you should be correct, and syntax is that the syntax of the sentence, the arrangement of words, that is something which is syntactic processing. So last few lines I will depict it. Don't worry about it. Just 1 minute. Okay. These are the last few lines.
Uh, Hi Pranav,
I,
am I audible?
you
Uh,
are,
uh,
yes.
yeah, yeah. This is Vijay Bhaskar. So actually, what is the sequence? I mean, when you're pre-processing all these, tokenization stuff, there should be a particular sequence, right?
Absolutely, yes. So the
What?
sequence is that first of all, whenever a given word is present, then you try to tokenize it. A given paragraph is present, you try to decompose a paragraph into sentences, which is sentence tokenization. Then you
Yeah.
try to decompose a sentence into word, which is word tokenization. Then from those words, you try to remove stop words. Okay.
Okay.
Then you try to do lemmatization, and the words with the same root word are being removed. Like running and ran, in both the cases, the root word should be ru and run. So what happens is that then you do lemmatization. I bring the words to the root word and only have set of that. So the words with different forms, same root words but with different forms are being removed. And after that, you do POS tagging, right? So, sorry, before that you do POS tagging. So run may be used as an adjective, may be used as a verb. So to make sure that we have both the runs taken into consideration as adjective as verb, you do POS tagging, and then you do the removal of duplicate words that are there. And after that, there is vectorization.
Okay.
Okay.
Thank you.
So yeah, we will do it. So POS tagging is done. Now there is text summarization, vectorization part. That is something which we will do. So see, very good question, and I was going to come up to this particular point. So first of all, you take the raw textual data that you have. After that, what you guys are basically doing is that you are decomposing paragraphs into sentences, sentences into words. Then you are removing stop words. Then you are doing uh, POS tagging or lemmatization, vice versa, in any order. And then the words which are being used in the same form, they are being deleted by the set keyword so that we only have unique values. And after that, what you will have, guys, everybody tell me, after that, you will have unique words with the respective forms in which they are being used. But can you feed the data in this particular format to the ML algorithms? Everybody guys tell me. Can you feed the data in this particular format to all the ML algorithms? No. Why no? Because ML algorithms are basically something in which you can just work on numbers, right? Yes or no, guys? So that is basically something with which you guys are expected to be very, very, very clear with everybody. So for that, what we do is that we try to do vectorization, right? So let's try to first complete text summarization. So there are two type of text summarization activities. First is extractive and second is abstractive. So in extractive, you involve selecting important sentences, phrases, sections of the original text and concatenating them into the summary. Whereas in abstractive summarization, it generates new sentences that convey the most critical information from the original text. So extractive means you just extract the sentences and move ahead with the next part. On the other hand, in abstractive, what you guys are basically doing is that you are getting the gist of that and giving a new sentence over there. Is it making sense to all of you guys, everybody? Perfect. So take a minute, go through this and do let me know if I can help you with anything, guys. Now, after that concept is done, the next part that I want all of you guys to take into consideration over here is this sentence, bag of words and vectorization techniques. So bag of words representation basically means that let's say you were having stop words. So it's like a list of words or corpus of words. So you can assume it like a bag in which all the unique words are basically present over here. So that is basically something which refers to as bag of words representation over here. Okay, everybody guys, is this clear? That is basically something which refers to as bag of words representation. Now, after this particular portion is completed, tokenization, vocabulary building, and next is vectorization. Let's try to discuss this. And in this, we are just going to discuss TF-IDF vectorizer because that is in our course curriculum. So as we have discussed that we cannot move ahead with textual data by common sense, right? We cannot move ahead with textual data. And hence, it is very important for all of you guys to understand that whatever is the textual data, it needs to be converted into numbers. So the process of conversion of textual data into numbers is called as vectorization, representing each document as a vector. So let me give you a very example. Python, Python, Python programming language. Okay. So what is basically going to happen over here is that if this is the text, people are going to create columns for each of the word. So one column for Python, one column for programming, one column for language. And what they are going to give is that how many times the given word is occurred. So 1, 1, 1. So now this vector 1, 1, 1 is so this sentence Python programming language is represented into a vectors 1, 1, 1. Right, this is a very simple example. This is an example of count vectorizer in which you simply count the number of occurrences of a given word and tell whether a word was present or not, and if it is present, how many times it was present. So obviously it doesn't make any sense because the same combination of words, if you arrange it in a different way, it can completely change the meaning of the sentences, right? Just 1 minute, there is I think a comment over here. Convert, exactly, correct, yes. So what we are basically going to do over here in vectorization is, in count vectorizer, as I have explained you in very short, every token, so this is a sentence, it would be decomposed into tokens. Every sentence that is basically present over here, it would be decomposed into tokens of words. And what you will basically implement after this is that you will basically try to get an overview, get an idea or get an overview about this one particular vector 111. Okay, or it may be 211. So means Python has occurred 2 times in a sentence. That's this part. So it simply counts the number of occurrences of each word in the document and converts it. It's very simple, not that relevant though. Okay. Now let's move ahead with the most interesting variant of tokenization, which is called as TF-IDF vectorizer, and it's by far one of the most simple methods that is available out there. What is this TF-IDF vectorizer method, guys, everybody? So in this TF-IDF vectorizer method, TF stands for term frequency and IDF stands for inverse document frequency. So it's term frequency, inverse document frequency vectorizer. So what happens in this term frequency is that you are basically gonna get that how frequently a word is occurring in the given document. Is it making sense? How frequently a word is occurring in the given document. More frequently is the word occurring, the more is the TF part for that word. As opposed to this, there is something which is called as inverse document frequency. Inverse document frequency basically tells that if a word is a very common word, if one given word with which we are expected to move ahead with, if it is a very common word, right? Like evaluate is a common word, importance, word, document, these are common nouns. You will observe over here that these words are basically something which are not like that discriminative, or it will not give you that much information about the portion with which you are expected to work ahead with. So it will downgrade the weight associated to with that particular token that is basically present over here, right? So now after this is done, so the formula is this TF into IDF. So T is the term, D is the document, right? So IDF is log of N divided by NT, where capital N is the total number of documents and NT is the total number of documents in which that term has been present. So if that term is present in a large number of documents, this will decrease. By the way, this will decrease, which will lead to reduction in IDF. So if a term is frequently occurring, TF part will be high, but it is frequently occurring in a lot of documents, then IDF part will be low, because then it means that it's a very common word that is used again and again and again. Is it making sense, everybody, guys, to all of you? So take a minute, go through this, and do let me know if I can help you with anything. So now after this is done, let us try to do the Python coding for TF-IDF vectorization. By the way, any questions or doubts? There is a comment over here, I think. What is document? No, it's not a page. Document means that data, total data. Let's say you're doing what you can say TF-IDF vectorization for spam email classification. So document basically means the total data that you are having, which are, that's the terminology used in MLP. Document means all the emails that are there.
Yeah, then I have a question, Prabhu. If the
Yeah.
total number, the total document is one, why the capital N? That itself is always one, right?
No. Capital N, just 1 minute. Capital N is the total number of documents, means total number of rows, how many emails you are having.
Oh, okay.
Every email would be a document.
Okay, thank you.
Yes. And then we have TF, IDF, vectorization. So what is basically going to happen over here is that you have importing important libraries, and you have from sklearn dot feature extraction dot text import TF-IDF vectorizer. Then you have sample arguments. documents is equal to first document, the quick brown fox. The quick brown fox jumps over the lazy dog. Then you have the lazy dog. Initialize the TF IDF vectorizer. Vectorizer is equal to fit and transform the data. TF IDF matrix is equal to vectorizer dot fit underscore transform documents. And then you have get feature names terms is equal to vectorizer dot get feature names. Then you have convert the matrix to a dense format. So dense matrix is equal to two dense print TF IDF matrix. And then you have display feature names. So for I comma doc in enumerate last line guys, just 1 minute, okay? In enumerate documents, print documents I plus 1 colon, and then you have for term comma score in zip terms comma dense underscore matrix dot to list. Print final thing, print term colon score dot point 4 f, and that should kind of give you the value. So this is the TF IDF matrix, okay? And then you have document 1, brown is having this weightage, dog is having this weightage, fox is having this, jump is having this, lazy is having this. Okay, the weightages that are there. This is the matrix. So 1, 2, 3, 4, 5, 6, 7, 8. Right. So there are 8 unique words. You can calculate 4, 5, 6, 7. Okay, 7 is done. 7, 8. 8 unique words are there. That's why you are getting a fixed length vector of 8. 1, 2, 3, 4, 5, 6, 7, and 8. Even here it's 8. Even here it's 8. And here are the weights for all the matrices. So take a minute, write this portion in your laptop, and do let me know if I can help you with anything, guys. Next part over here is this. Can you? Yes, yes, I am going to scroll down. I was waiting for all the learners to type the first part, but yes, I'm going to scroll down. Don't worry. So guys, I hope this part is completed. Everyone, right? Now, let me see. Text rank algorithm, sequence to sequence models. Okay. So there is a text rank algorithm. Okay. And it is an unsupervised graph-based ranking algorithm, again in your coursework, primarily used for extracting the keywords and then summarizing it. So if you use ChatGPT, if you give a big story to ChatGPT and if you ask it to summarize the given document for you, then it can do that particular thing based on this particular part or this particular activity, right? So basically, it uses Google's PageRank algorithm. The key concepts are basically mentioned over here. It's theoretical, there is no live coding. And here are the steps that are there, which I think all of you guys will know. So first is just the pre-processing, which we have been doing since the start of the session. Next is that there is a graph that is constructed with nodes and edges, and cosine similarity is calculated. So do you know that every word, let's say U bar, is a word which is of some vector, and V bar is again a sentence with 0, 1, 0. So there is cosine similarity U bar dot V bar divided by mod of U bar into mod of V bar. So this is basically something which is going to give you cos of theta, which is the similarity between these two vectors, cosine similarity between these two vectors, right? So cosine similarity is used to judge how similar two words or how similar the analogy between two words is, right? So this is basically something. Sequence to sequence model is something which we will cover up tomorrow, because sequence to sequence models is again a very big coursework, right? There is encoder architecture, decoder architecture, LSTM and everything, and then there are evaluation metrics. So you can read till this part, just 1 minute, before named entity recognition. Till this part, you guys can read this before named entity recognition. We will try to complete it tomorrow, right? So tomorrow we have, okay, tomorrow we don't have a lot of things. Tomorrow we will be able to complete all of these things. We'll cover up, don't worry. Now about the live coding file, this live coding file is something that I will give to course coordinators and they will share it with you maybe in 15 minutes from the session is done. Yes, and share the document. I will give you the link for the document. So have you enjoyed the session, everybody? Both the sessions that we had today, have you enjoyed today's session? So I have tried to include coding, I have tried to give you reading material, and I hope that this definitely enhances the level of skills that you already are having. You guys are great contributors in your field, in your subjects, and I understand the job of the teacher, because I myself am working into this particular role on basis, but I understand the gravity of this particular role, and I'm 100% sure that all the efforts that you guys are taking right now, it will definitely help the learners, because uh, whatever experience I have into edtechs, all of them are mentoring the learners based on Python, SQL, but the main part is that uh, Python, SQL, Power BI, these things would be outdated in a year, I think, according to my calculations, I think in a year or at the max 2 years. This is basically something which would be totally outdated. So people would have created automated APIs for this, right? So in such a situation, to support our what you can say, to support our candidates, to support our students, this is a great field. And I think uh, right now also a lot of universities are having bachelors in data science, right? So I think in the coming years, generative AI, normal AI, generative AI, all of that would be a specific specialization in masters, right? So yes, with that being said, I think it's a really good time to wrap up our session over here for today, right? Anybody else? Any questions, doubts, concerns, guys? Everybody?
Okay, sir. With this, we'll
Perfect.
conclude.
Yeah,
With this,
we will
we'll
conclude.
conclude
Yes,
the today's session. Again, tomorrow at 10 a.m. sharp, we will again start the session.
absolutely. Thank
Thank
you,
you, sir.
everybody. Thank you. Bye. Have a great evening. Bye.
For today's session, any assessment we are going to share, sir?
Not assessment, but coding file is something that I'm going to share with the course coordinators. Okay, and I have a given reading material because they have to read topics. So I have given the reading material. Okay. Thank you. Thank you, everybody, guys. Bye.
Thank you, sir.